Okay, guys, we are back again with our science class, and today we are going to finish what we were looking at in our last videos, and we are going to just finish up those notes. So this class may be a little shorter than others, but don't fret, don't fret. We shall come back and do some more videos. All right, so great. So yes, we talked about the continental drift in the two classes ago. We did that. Talked about the elements of the oceans, salinity, and we looked at last time, or we started to look at the three major movements of the oceans. Now, before we continue on with this is chapter 5. And in the last video, on the link, you should be able to see there the worksheets for chapter 5.1 and 5.2. Okay, so keep those in mind. We'll come back to those in a little bit. And I will also put a link to those so that you can get to them on Google Drive and print them out, work on them, and send them back to me. All right, and so just keep that in mind. And we'll talk about the homework after we get through with this class. So we're looking at three major movements of the oceans: the tides, the waves, and the currents. Now, you already have all this information, so you don't have to write any of this down yet. We talked about the tides of the oceans are the rise and fall of sea levels. Okay, and the gravitational force of the moon, the sun, and the earth are what affects primarily affect the tides. All right, we said that the largest tides in the world are found in Nova Scotia, the Bay of Fundy, right smack in the middle of New Brunswick and Nova Scotia. All right, so that's not well, it is far from here. I was going to say it's not too far from here, but yes, it is. You could drive up there, but because of coronavirus, ta-da, we can't go anywhere, but that's okay. Anyway, so yes, the Bay of Fundy, and this was a picture. You could just tell how the difference in the level of the water. If you notice in this picture here, that's where the level of the water is, and when you look at it over here, I mean, there's a guy standing right there. Let's say even if he's 6 foot tall, right, just as tall as I am. Don't laugh, that's not funny. I mean, you still have another maybe 10, 15 feet to reach the level of water on this side over here. And yeah, that is about 15 or 20 feet difference in water right there. And so we talked about other places where the tides have become famous, or the place is famous because of the tides. And we talked about Mount St. Mitchell, my beautiful castle, my soon to be future home. And like I said, you are all welcome to come. Not. Yeah. Here it is again. This place is beautiful. Let me tell you something. If I ever go to Europe, that is one place I want to visit. That is just nice. I mean, that is just beautiful looking. Anyway, so there you have it, low tides and high tide at Mount St. Mitchell. All right, so we talked about the two main causes being the moon, the gravitational pull of the moon and the sun. And we talked about how the gravitational pull of the moon is the one that affects the tides the most, just because it is closer than the sun. And so we talked about that. We talked about how it creates a bulge on either side, right? And here's another example. When the sun, the earth, and the moon line up, We have whether they line up at the new moon or at the full moon. That usually leads to spring tide. Okay, spring tide, where we're gonna have a big difference in between the high tide and the low tide. And then whenever they line up in a right angle, right, either here or here, there's your right angle, then that leads to a nip tide. Okay, nip tide. And so we talked about that as well. All right. We talked about the waves of the ocean as well. We said they are formed by winds disturbing the top layer of water. And we said that waves are motions that carry the energy of the sea. And we talked about how different types of energy that are found in the sea. One of them is the tsunamis. I did spell it correctly this time. Yay! Thank you, thank you, thank you. And we started talking about, or we talked about the 2004 Indian Ocean tsunami and how it affected 14 different nations. Thousands of people died during that tsunami. And the epicenter, or the reason why that tsunami took place, was because there was an underwater earthquake right there, right off of the coast of let me see what Sumatra is the name of this island right here. Okay, and so in the country of Indonesia, and a lot of people died. Just a quick some pictures of the height of the water. Water just dragging and destroying everything in its sight or in its path. Water has no sight in its path. And we said that really this is not one thing, or a tsunami is not something you want to be a part of. Okay, it is just miserable. Another picture of India, I believe it is, the eastern coast, southeastern coast of India, that was ravaged by this tsunami. All right, so today we're going to be talking about currents. Okay, so tides, waves, and currents. And now you can start writing down. Remember, you need to make sure you're writing down this information, and make sure that when you do your work, you send it in. By the way, let me just say that I have not received some work from some of you. Now, I don't want to name any names, but, well, next video, if you have not sent any work, your beautiful name or face shall be plastered on these pages, okay? So get your work in. You can't be that busy. All right, so the ocean's currents. Currents are massive movements of water that occur beneath the oceans. They differ from the rest of the water in the oceans in salinity and temperatures, and usually travel thousands of miles. If I remember correctly, some of these waters have a 100-year cycle, I believe I read correctly. And so some of these movements, they move a lot of water, or these currents move a lot of water, and obviously it takes time to move the water all the way around the circuit that they follow. But they are massive movements of water beneath the oceans. Okay. All right, let's continue. Now, if I'm going too fast, you can obviously always hit pause, people. All right, good. Let's continue. Now, currents are caused mainly by three things. Number one, winds, or the wind, the rotation of the earth, and the sun's heat. Okay, they are mainly caused by these three things. Now, the currents, they follow a counterclockwise pattern in the southern hemisphere. So that would be South America, Africa, India, Southeast Asia, Australia, all of that. Okay, so in that part of the world, currents follow a counterclockwise pattern. And in the northern hemisphere, that would be where we are, North America, most of Asia, all of Europe, they follow a clockwise pattern. And we'll see some pictures and graphs on that in a little bit. Okay, so currents are caused mainly by the winds, rotation of the earth, the wind patterns, rotation of the earth, and the sun's heat. Well, and the reason for that is because some of these patterns or some of these currents, some of them are cold water currents and others are warm water currents. And they do affect the temperature of the regions where these currents start, where they pass through, and where they finish. All right, great. Let's continue. Now, there are two basic categories of currents. Okay, so we're going to be talking about primary marine currents. There are two basic categories, and then we have some subcategories under at least the first one. The first one is known as the surface circulation currents. And in this current, you will find that it includes, or in this category, it includes what are known as gyres. And gyres are large continuous systems that occur in the Pacific, Atlantic, and the Antarctic Oceans. And now these large continuous movements are currents, and at least in these three oceans, they are linked by these large continuous systems. Okay, and so in certain areas, whether you're in the Pacific, Atlantic, or Antarctic Oceans, they have a particular name, and once they enter another ocean, the name changes, but the gyres link these three oceans that fall under the first category. All right. All right, let's continue. Sorry, I almost sneezed there. Whoa. I like sneezing, but not in the video. All right, great. Let's continue. So, two basic categories. Next, um, under the surface categories, so the surface circulation, we have subcurrents. And one of them is they are known as rip currents. And rip currents are strong, narrow currents that carry large amounts of water back out to sea. And actually, this is the current that you would feel when you are standing at the edge of the ocean, at the beach, and the water comes out. And then when it pulls back in, all right, all of that amount of water is being dragged back out to sea, and you can actually feel the sand from beneath you kind of being pulled back. Well, that is a rip current, okay? And I'm sure that we have all felt that when we've been out on the beach. And well, that is a current that is actually a subcurrent that is taking place right beneath your feet, literally. All right, great. Let's continue. So we have subcurrents. One of them is the rip current. I'm sorry. And this is actually the rip current is actually no, I'm wrong there. Rip currents carry large amounts of water back out to sea. Um, Undertow is what I was talking about. Yes, the undertow. This occurs after a breaker crashes on the beach. So that would be like a huge wave. Water rushing back to the ocean flows beneath incoming swells or breakers. So actually, this is what I mentioned about water being pulled out from under your feet, and you can feel the sand kind of disappearing, and you feel yourself kind of sinking down into the sand. That is known as undertow currents. This back here, rip current, is actually a current that will take you out to sea, and you can actually drown in a rip current, not so much in an undertow current. Okay, great. So let's continue. Once again, remember, you just pause the video if you are writing down and it's taking you a while. All right, so let's go back. So we have two types of basic categories of currents. One is known as the surface circulation, and that's only about 10% of the world's water will be found, and the seawater will be found in these types of currents. And subcurrents under that are rip currents and undertow currents. Okay, and here is an example of the currents that are found in the world. Okay, so notice here we have the southern hemisphere. So actually, it's a little lower than that. The equator is like right here. Okay, so there we go. That's the good line. All right, so everything under that is the southern hemisphere. And as you can see, all of the currents to the south follow a counterclockwise pattern. Here we go. Okay, counterclockwise. Now everything to the north follows a clockwise pattern. Here's one. Here's another one. Okay, and here is another one over there. Okay, so keep that in mind. Everything to the south, counterclockwise. Everything to the north, clockwise. And all of these currents, especially the major currents, have names that go along with them. And as you can tell, they all meet up with other currents. So for example, we have the East Australian current, the EAC, made famous by Nemo, right? Or by Dory in famous Nemo. The EAC over here is actually a part of the South Pacific and the Peru current that comes around this way, the South Equatorial current. And down here, when we get to this side, it becomes the East Australian current. And so it just goes back in a circle. Down here, we have the South Atlantic, the Benguela, the South Equatorial, and down the Brazil current. Okay, and so they are all connected, and they follow the wind patterns of the currents follow wind patterns. Okay, the wind patterns that are established by God in the world, and so these currents also follow the wind patterns that have been established. By the way, years and years and years ago in the book of the Psalms, David spoke about the ways of the seas and the ways of the ocean. And people thought that he was crazy, or that, how could David know there are ways or roads under the sea? Well, because God revealed it to him. But the Bible does speak about this, and David wrote about this about 800 years before the Lord was born. And so the Lord revealed that to David. Okay, great. Let's continue. All right, let's see. Let's go on. All right, good. So the two basic categories. First, we have the surface circulation, which covers about 10% of the seawater. And then we have deep circulation, and that is also known as thermohaline or thermohaline circulation. and but it's commonly known as deep circulation. That means that these currents under this category are deeper into the seawater or in the ocean, and they cover about 90% of the sea water or the ocean's waters. Okay, so two basic types: surface circulation and deep circulation. All right, let's continue. Now, let's talk about some major currents around the world. Some major currents. The first one, and probably the most well known, is the Gulf Stream. And the reason why this one is the most known and the one, as you see there on your notes, the most studied, is because it affected trade. It has affected trade between Europe, Africa, and the Americas for centuries. Okay, and the pirates, the Spanish Armada, the Portuguese, the British Navy, and the French Navy. All of these different groups benefited from this current. Now, they did not know it was there until later on, and we'll talk about that at the end of the class. But the Gulf Stream, it is the most studied current. Now, this current has three types of currents that make it up. You have the surface current, you have the subsurface current, and you have a counter current. And we'll see those in a little bit in a diagram in the next slide, I believe. Now, this current starts north of the Grand Bahama Island, down in the Bahamas, man. One day I'm going to go to the Bahamas. Oh my gracious, it will be great. And I will have a nice little hut in the beach. My wife will be sunbathing and I shall be sleeping. It'll be great. And anyway, so I need to go to the Bahamas. I actually have a friend that lives in the Bahamas. Maybe I can stay with them. Anyway, let's continue. So it starts north of the Bahamas. It flows northward along the eastern coast of America or North America. And it actually ends up in the North Sea. That would be north of Great Britain, Ireland, Scotland, and Northern Ireland, all of that. Between the Great Britain, and Iceland, actually. Now, this Gulf Stream current is responsible for mild weather in Great Britain and Norway, and it also brings a lot of heavy rain. Now, if you were to go to England, you will see that they do not have as cold of weather, as cold of a weather or weather. Their weather is not as cold as ours. Let's put it that way. Even though they are farther north in latitude, we are actually farther south when it comes to us being in North Carolina. But we have colder weather here than they do in Great Britain. Why? Because the Gulf Stream is a warm water current and it is picking up all of that warm, beautiful water from the Caribbean and is bringing it to the British, not leaving it here with us, but taking it to the British and dropping, yes, a lot of water, a lot of rain, but also very mild weather. And the same is true for Norway. All right, let's continue. Let's continue. Now, let's see here. Here is a picture. It's a little pixelated, but I believe you can see this. All right, so now the Gulf Stream, it actually is a part of this beautiful cycle right here. Okay, and remember, we're in the northern hemisphere, so the cycle is going to be clockwise. So it starts down here right there in the Caribbean. It comes up the eastern coast of North America, and it meets up with this Labrador Current. That is the counter current. Okay, so remember, this Gulf Stream has a surface, subsurface, and a counter current. Yeah, counter current, counter current. Say that 5 times. That make it up. Now, once it gets here, it is met with the North Atlantic Current and the Labrador Current. This area over here is known as the Labrador Sound up in Canada. and and so the waters coming down from Greenland meet up here, and the waters that are up in the North Atlantic, they meet up with the Gulf Stream. But we have a lot of water coming up from the Caribbean, and it goes all the way over here, and this is where all of it basically lands. And then it comes down the Canary Current. You have the Canary Islands down here, and so those waters come back down. You have the North Equatorial Current that pushed them this way, and then we continue on with the cycle once again. Okay, and so wow, that is a lot of. Let me erase some of this stuff. Well, that's not what I wanted to do. This is what I wanted to do. And so that's a lot of red there. Okay, so you get an idea of where this current is. Okay. Like I said, this current is the most studied just because it's been one that has been used the most, especially back in the 16, 17, and 1800s, especially when the slave trade, well, I keep doing that, I'm sorry. When the slave trade was going on, if you remember the slave trade in your history class, there was a triangle. Okay, you had a triangle of trade that was going on between North America, Africa, and Europe. Okay, so from Africa, we got the slaves that came to South America, the Caribbean, and also North America. And then from North America, you had going up to Europe. You had goods going to Europe like cotton and tobacco and stuff like that. And so, and then from here, from Europe, you had gold going down to Africa, gold and money, and in exchange for slaves. And so, there we have this triangle trade that was going on. But what did they use? They used these currents to help speed them along. Now, they weren't used as much. Some of these sailors were just getting out there and following the stars, but most of them didn't know that there were these currents there that would help propel their ships and get them to their destination a whole lot faster. All right, let's continue. Now, so that was the Gulf Stream. Another major current is the Kuroshio. The Kuroshio. There we go. The Kuroshio current. And the Kuroshio current is actually the counterpart of the Gulf Stream. Now, this one is found in the Northwest Pacific, okay, in the Northern Pacific Ocean. And it is known as the Black Stream. And the reason why it's called the Black Stream is because its water is very, very dark. It's a dark blue water. Okay, that's the only reason. You say, Pastor, why didn't they just call it the Blue Stream? I don't know. I guess it didn't sound too menacing. The Black Stream sounds more wicked. Anyway, now this stream affects weather in Japan, in most of the four major islands of Japan, as well as the northwestern parts of North America. So that would include British Columbia, up in Canada, Washington, Oregon, and parts of northern California and parts of Alaska. Okay, so the Kuroshio Current. Kuroshio. Kuroshio. Ah, yeah. Anyway, let's continue. And here's a picture of it. Okay, like I said, once again, this is all of these currents meet, and this one, because we are in the northern hemisphere, it also follows a clockwise a circle. And so we have the Kuroshio current starting right here. Okay, it comes off of the coast of Philippines, which is right there, up on the eastern side of Japan, affecting all of Japan's weather, and then coming up across the Atlantic and coming down here. And here we have British Columbia, Washington, Oregon, as well. Okay. And so all of this water, as you can see from the red lines right here, this is also a warm water current because you have all of the water coming up. This is the equator right here. So this is warm area. Okay, all of this water is warm. Is being pushed by the wind, being pushed out to the Asia side, and so this Kuroshio current is warm water. Okay, warm water, and you can see here that it is part of the equatorial current, the California current as well. Okay, all right. So this is the Kuroshio current. Good. All right, let's go. They have one more, I believe. Okay, the Humboldt, or better known as the Peru current, the Peru-Chile current. Now this one is different from the first two that we saw. This is actually a frigid, shallow movement that starts in the South Pole and flows north along the west coast of South America. So this movement, the Peru Chilean current, actually starts down in the South Pole, and that is all cold water down there. So this is frigid waters. Okay. Now the difference between this current and the other two is that it carries an abundant load of nutrients upwelling. Now, upwelling is actually upward movement of water below the surface. And what that does is that it brings a lot of nutrients, okay, down from the sea. That upward movement of water lifts up the nutrients that are found in the floor of the ocean, and it brings up a lot of nutrients, a lot of plants, a lot of food for the fish. And so that's why these areas down in South America, Chile, Peru, Ecuador, the western part, the western part of Colombia, you have a lot of fishing and a lot of fishing down there, and they eat a lot of seafood. Okay, mariscos they call it. It's good stuff. Ceviche especially. Oh my goodness, that stuff is so good. If you never had ceviche, you need to get some. But all of that, the reason why they have such a great fishing industry is because of the current, the Peru Chilean current, and the upwelling of the water. Okay, again, upwelling is upward movement of water below the surface, and when that water moves up, it brings up the nutrients that are down in the depths of the sea. It attracts more fish, more sea life, and voila, you have the food that you need. All right. And here is an example of it. Okay, so it covers most of Chile, uh, Peru, and Ecuador. Okay, and so in this Peruvian Chilean, the Peru Chilean current goes back out into the Pacific, mixes with the equatorial countercurrent, and it becomes part of the East Australian current. All right, and so you have the counterclockwise movement in this current as well. All right, guys. Now, to finish up today, this man right here, famous for being in our $100 bills, ching ching, Benjamin Franklin. Now, he was not a president, but this man right here was a statesman. This guy was a politician and mathematician. He was a scientist, and he was also not Osho, also an oceanographer. He was actually one of the first to recognize and study ocean currents. And he did that on the Gulf Stream current. And he had a brother, I believe, or a nephew, who was a sea captain, and he asked him about the direction and the currents out in the ocean. And his nephew, I believe it was, you'll read it in your chapter. He did mention to him that yes, that there are currents, and that they actually followed one that would take them to England a lot faster than any other direction that they could have gone. And so he was one of the first men to recognize and conduct studies on the Gulf Stream current. And because of this, because of his studies, shipping was affected later on in his life, and even after he died and Benjamin Franklin died, sailors began using the information that he was able to gather to cut down the amount of travel time between North America and Europe. All right, that's Benjamin Franklin for you. Nice guy. I love seeing him in the green paper. Yep. All right, great. So that's it. We'll leave it here for today. And voila. Oh, wait, one more. Look at that. Yay. All right, people, this is your homework. And it says you need to read chapter 5. Read chapter 5. And you are to do worksheets 5.1 and 5.2, dos, and turn it in by Tuesday at 8 p.m. All right. So this is your Friday class. So that means that on, on Monday, we will not have a video to look at, but you will have this work to get done. All right. So you need to read chapter 5. I just gave you the highlights. Those worksheets have several questions on them. Make sure that you also write down the meaning or the meanings of the words at the top of each worksheet. Okay, so don't just leave those blank. Some of you are leaving questions blanked, not blanked, but blank in your homework. Do not leave anything blank. Don't tell me, oh, this is the best I can do. I don't want your this is the best. I don't want excuses. I want results, people. All right. So you have until Tuesday at 8 p.m. to get this done. All right, guys. We'll leave it there for today. And next video, we'll be looking at chapter 6. Chapter 6. All right. So thank you for attending, and I hope you enjoy your homework. We'll see you next time, children. All right. We'll leave it there. Have a good time, and we'll see you on the next video.